Hey yo guys, this is another this video is to show how to use Subclass resolving frame analysis. We're doing a frame analysis. So basically, this problem is provided by the Subclass solve, and this is a verification documents with regards to the subject of frame general rulings. So basically, there is a scenario here where we are asked to analyze the frame by having seven load keys. So basically, this is the load case one or soft weight. We analyze only the soft weight, and then on the load case number two, where in a small member there is a distributed load on the small member and end load on the end. So here there is a moment and there is a point load acting on the middle joint, and then here there is a distributed projected load, and this one in the load case number 5 there is a load acting directly on the frame on each frame local axis, and then there is a trapezoidal load, and then there is a load acting at the midpoint of this member. So let me show you. So again, there is a provided hand calculations. There is a provided hand calculation. This document you can find it in the software package sub 2000. Then this is load case one. This is the delta. So basically, we are asked to find the delta on the joint number 3 for the load case 1, 2, 3, 4, and then for the load case 5, 6, 7, we are asked to find out the value of x on the joint number 2. So again, there is a sub 2000 answer, and then there is an independent calculation which is shown in the page after this, and then what I'm going to do is to show to you how to get this value. Okay, so let me start. So again, I'm going to open the sub 2000. I go for the units of keep feet Fahrenheit, and I will choose grid only. So as you can see, there is a 3 grid for the x direction and the 3 grid for the z direction, so we have to make it consistent. So 3 1 3, and then for the x direction it says 4 and 8. So initially I will put 4, so they will both equal. For y direction is equal to 1, and then for the z direction I will incorporate 10. Even if it's shown it's 10 and 6, I will change it later. And then I will click this, close this 3D view, go to the XZ, and then right click this grid point, edit grid data, modify, and then in display grid as, I will click spacing, and then I will change the value of 4 into 8, and then Z is, instead of 10, I will change it to 6, and then click OK, and then click OK. Now I have to draw the prime. Remember, I have to make sure that the frame nodes are the same, so we have to make the member by starting at the bottom, go to the middle, and then going up, and so we could have a same label. However, you can change it if it's in case that you made it incorrectly. So I will click frame, so it says from here, so joint 2, joint 3, and then that joint 4. Okay, and then after that I will assign the restraint on the joint tree, where as you can see there is a roller on the Z direction, so that's the only movement allowed on this joint. So I have to make it restrain on the translation 1 and translation 2 and allow a movement on translation 3, and I will click OK. So I will click the bottom joint, and so this is a fix. It's not fix, it's a strain on the uh, movement on the X, Y, and Z direction. So I will select this translation 1, translation 2, and translation 3. And then remember that on this document we only bending deformation are considered in the analysis. So there is an important note: shear and axial deformation are ignored. In SAP 2000, this is achieved by setting the property multiplication factor per area to 1000 and setting the property multiplication factor for shear area. So basically we are asked to to modify the area and the shear area for the shear analysis. So because we would just wanted to have an analysis on the bending only, so we have to select all the members, click frame property modifiers, and we put the area to 1000, and then we shear area is 0, and then click OK. And then we select all the member, click assign, uh, frame section, click add new properties. In frame section property type I will select concrete, because as you can see there's no box type here. I will select concrete and I will click rectangular. Then says that the area is 144, but I think it doesn't matter because as you can see we multiplied we multiply our area by 1000. So okay, so 144 is actually a 1 by 1 feet, so because it is inch squared, so 144 is square root of 144 is 12, so it will be 12 or 1 feet by 1 foot. So then I will click OK, and then click OK. So we are ready to assign the load case. So we start with the load case number 1. So self weight is 0.15. So first I'm going to solve this load case number 1. And now we check if the answer that we will get is the same as the answer in this one. So load case number 1, we try to analyze it. So it's just only a self weight of 0.15. So basically we click define load patterns, and then we type load case 1. Okay, and then it says that we just analyze it, the dead load. So the dead multiplied by 1, I click add new load pattern, click delete load pattern, okay, load case, and then click OK, and then define load cases. We would wanted to erase this load case because we don't want to analyze that, and click OK. So but first of all we have to check if the unit weight is the same as the unit weight for the frame section. So assign, we change the unit to, so 0 supposed to be 0.15, assign frame section modify, so unit, okay, so it's 0.15. okay, so if we run this, so I have a load case now, which is define load